Hi everyone, this is Captain Ray Vetter coming to you for SE301. Today we're on lesson 5, Functional and Requirements Analysis. It's our second task in the problem definition phase of the SDP. Before we fully jump into today's material and content, put a picture on here on our title slide of cadets completing the IOCT over in Hayes Gym. And beneath it you'll note we have a statement written with a bunch of different colored components. The cadet shall complete the IOCT within the specified time standard in PTs at Hayes Gym. Now, if we can break this down, and we'll talk about writing good requirement statements later, but what this statement says is what we're concerned with: the cadet shall complete a function, complete the IOCT. How well is within the specified time standard, and we know there's different time standards for genders. And then under what conditions? Our conditions are you're wearing your PTs and you're performing it in Hayes Gym, right? You're not wearing your combat gear, you're not wearing any kind of body armor or ACUs or boots or anything like this. You're wearing your PTs and it's always happening in Hayes Gym. So that's our environment or our conditions where we are performing we have to meet that requirement. So that is how we could write a requirement statement. That's just one example. We'll have several others in today's class, but just so you're thinking about it as we go forward. All right, and today, if we look at our course roadmap, we are now on to requirements, functional and requirements analysis, which is our second task in our problem definition phase of the SDP. My big three, my key takeaways from last class where we did an intro to problem definition and stakeholder analysis. So first up, no one stakeholder is always the most important. So there may be times where our decision authority is the person we really want to make sure we capture all their needs and we really kind of cater to them. There's certainly going to be other times where that person might be the owner of the system or the client, or maybe we have to balance everybody's different perspectives equally, right? So no one stakeholder is always the key or the most important in any given situation. Secondly, choosing the right method to elicit information from stakeholders, right? So we talked about 3 ways we can elicit stakeholder information. We talked about our interviews, our focus groups, and our surveys. And there's different situations where you want to use each of those tools. So if you're talking to a very senior leader, you're probably going to want to do a one-on-one interview versus if you have thousands or tens of thousands of participants, that's probably not feasible and you're going more along the survey route, right? So picking the right method and matching that to your stakeholder population is an important decision to make. And then get good at building an FCR matrix. And hopefully everyone is familiar with FCR being the findings, conclusions, recommendations matrices, right? So just stacking that up, building your columns, and being able to spell out and clearly show what you found from your stakeholders in your research, and then what you went on to do, what conclusions you were able to draw and synthesize, as well as your final recommendations that you will take forward into the rest of your analysis. So get good at the FCR, as I said there. As for today, what are we going to cover? We're going to start by talking about needs, wants, and desires, hit on that a little bit more, and then we'll talk functional analysis, and then shift gears a little, although quite related, into our requirements analysis. All right, so after we do our stakeholder analysis and research, our next task is what we call functional and requirements analysis. But really the question is, where should we start? And we always should tie it back to the stakeholders, right? That is key. What the stakeholders are the reason we have funding. It's the reason we're doing systems analysis and trying to ultimately make a decision and implement a solution. So where do we start? We start with those stakeholders' needs, wants, and desires. And I've said in lesson 4 that the order of those 3 words, needs, wants, and desires, is important, right? So needs, as you can see here, are something that are essential criteria that our system solution must exhibit. They are must-have requirements, no-fail missions, if you will. Our wants are other features or specifications that certainly can help our system perform better, but not necessarily required. They're things that kind of differentiate our different alternatives, right? So for example, if we're considering a car, we might say, hey, we need to be able to achieve at least 20 miles a gallon. We want to be able to, transport 7 passengers. So the need would be essentially the bare minimum requirement versus the want, transporting 7 passengers. That's a should have, but if we don't and we can only transport 5, maybe that we would still consider a car that transports 5 people. And then finally, at the bottom, our desires are our nice to haves. It gives us that margin of excellence, that added little bit that puts us over the top, which we will talk about when we get to our scoring models. So needs are essential, wants, we should have them, and desires are nice to have. Those will directly feed into our system requirements, which then help us do our functional and requirements analysis. All right, so our system requirements are requirements that the system has to achieve. So when we start talking about requirement statements, we can have requirements for small elements or subsystems, or we can have overall systems requirements. Overall systems requirements, as we'll give an example later, account for the entire system and all its components and all the interactions that are going on beneath it. Typically, system requirements are captured in what's called the system requirement document, which if we're looking at in the systems in engineering realm and standardization, that document is your sole source for where you would look if you were looking for performance requirements. That we'd put it all in one spot, and then we can always point to our requirements, our system requirement document for those requirements that we're considering. All right, our functional analysis, this is what we're going to get into first here, are essentially they are the delving into the tasks, actions, or activities that we need to perform to achieve some desired outcome. Okay, so we will be talking about different ways we can perform functional analysis, but essentially we want to consider the system and then what processes or activities do we need to actually execute successfully for the system to be a success. So that's what we're going to talk about first here. Before we go any further, want to make sure we're all on the same page. What is a function? You see it right there. It's a characteristic task, action, or activity that must be performed to achieve a desired outcome. And we always write a function in the verb object form. I'll give an example in a bit, but verb object is very, very important. All right, in the system engineering world, that is the standard that we all look to. So verb object is how we want to build out our functional statements. Now, when we do analysis, our functional analysis is going to consist of identifying our functions and their interactions, and then essentially build them in a way that shows coherence towards a larger system goal. And the functional hierarchy, you will see in a second, it is how we can display it to show functions and then sub-functions that are nested and supporting higher level functions. You've seen hierarchies quite a bit, I'm sure, at this point in your military careers at West Point, and we will use hierarchies as well, both for functional analysis and when we get to value modeling. All right, so the key when we're talking about functions is we want to talk about what the system should do, not how the system will do it. So I know you all have been with this remote learning environment we're working in, very familiar with your computer. So we can see here, if we're talking about different components of our system, if we're talking about data processing, the data processing device, the quote-unquote solution would be the CPU. However, the function that it is achieving, that's what we're trying to get after with functional analysis, is actually processing data. All right, if we're talking about inputting information into a computer, our input device, the keyboard is a way to do that. However, that's how we're inputting data, not our function. Our function would just be simply to input data. Similarly, our monitor is a way to output data, right? So our function there would be output data, and we do that through a monitor. Our monitor is the tool or the solution. All right, and then finally, if we're talking about data storage, our function would be store data, and we can do that through a disk drive or through the cloud or some other way we can store data. All right, so key differentiator is we can see on the right we had verb object. On the left we have different solutions or tools that help us perform that function. So really when we're talking functional analysis, we want to be thinking in terms of the green, not the red. Functional analysis is done quite a bit, so you can see here how NASA does functional analysis if we're looking at an airplane. So if we have any aeronautical engineers or future pilots in the audience, you can see in most every case they use in red the functions, right? So you can see in black you have the parts of the plane, and in red you have the functions. So you have the rudder that's going to change the yaw, the vertical stabilizer that will control the yaw, and right all the way around. Now the only one I would maybe disagree with a little bit is the cockpit. They said command and control. That's not following that verb object convention that we have, but otherwise I think they did a good job of sticking to verb object.